Thank you very much. I'm going to be talking about a way to work on the following topics. First of all, I'm going to talk about the objectives. That is an enhanced onset damage detection and very high cycle fatigue test, adopting the proposed methods and recommendations. I'm going to be talking about the current cycle setup, the current the experimental setup, and 3 methods that will allow to detect damage at the beginning, at the onset. This work is based on experimental results and are verified applying to these experiments. And I also use a frequency split, flexing frequency split indexes that are recommended from a previous talk that I had on Monday, and I give up the conclusions. First of all, I was in a sabbatical year from 21 to 22 in France, it's so difficult to see, in a laboratory, and they were working on this kind of test. Actually, I want to say that there is no fatigue limit. We need to increase the security, and we have to develop standards in accordance to current fast-paced manufacture. It is important to characterize materials and the manufacturer in the cases of operation in the gigacycle fatigue, which is the vibration operation. You know, you always have vibrations. Right now, they are doing typical test, fatigue tests are 20 to 100 hertz. And with this technique, they are going to 20 to 40,000 kilohertz. What I do is I propose to add a flexural measurement that is not considered, currently is not considered. And the benefit is to compare simultaneously the measurements in both directions. And I come up with some expressions and analysis. I find the initial damage levels or initial damage methods before collapse. This test that I am going to present showed a problem where there were no collapse on the probe. On the right-hand side, on the left-hand side, sorry, we can see the typical measurements with the actual measurements that they are using in the current experiments, where in the horizontal axis is the time and the vertical axis is the vibration, actual vibration in the same sense as the excitation. And this on the right-hand side corresponds to the flexural vibration, the channel 2, the one that I recommended to include or to add to the current setup. This is called the flexural channel 2. Provides much better. These two are simultaneous. They're measured simultaneously. So this one you cannot see practically anything. Nothing interesting here to tell you about the state of the probe, the condition of the probe. In contrast, here you can see some actions here. And of course, here a huge trend in the vibration, flexural vibration, that will provide information, very useful information. If we make a close-up of the interesting part, these 2 slides, these 2 responses are simultaneous again. This is the actual response, vibrational response, and this is the flexural response at the same time. close to the end of the test. Here in this left-hand side, we have the typical equipment that they use. Normally, they only have a laser vibrometer measuring the toe of the probe, and you have the horn here, the exciter. This is the Branson exciter, and you have the whole control system. And here I propose to add a second channel 2, say channel 2 that measures orthogonal to the red one, to the initial one. And this is the probe that they were using, typical rectangular probe, hold it at there in where the screw is. And here's a mode vibration, actual mode vibration, using simulation in finite element. Here they have the method, the actual excitation frequency, where you try to use the anti-resonance frequency here, so you will not use too much energy. Here is the same thing, but in absolute value of the transfer function. Here is the phase of the transfer function, where you use the phase of the response in order to control. The control is based on the phase of the actual vibration. And here we have a method that failed, which is the nonlinear acoustic emission criteria. In this case, it didn't seem to work. I must apologize because my students, this is not the exact response, the exact calculation, but their first semester, master degree first semester. So, I mean, it's too much to expect. So, but it didn't work. I tried to use that method, but maybe because this is mechanical vibration and not acoustic emission frequency range, didn't show up and too much information. Now, these are details of the test. The triggering data was every 4 microseconds. See, so here we have a close-up view of the data. See, and we have about 12 measurements each cycle, and actual cycle. Here in the right-hand side is the frequency, the spectrum, the frequency spectrum of the radial axial one. Here, the first method for damage onset, it is, I rediscovered the warm water recipe because I talked with some people here yesterday that they have a machine and they use the same ID. See, I just learned it yesterday, where they use the change in the stiffness. And you can tell by the change of the stiffness that it should always go down to see when you might have problems where you start having damage in your probe. See, you can see here, the changes going downwards. This is the frequency in the vertical scale, and in the horizontal scale are the segments of 128 segments out of 33 seconds that the test lasted. Here we have different ways to obtain the spectrum. See, where I have here a whole period, and it is not very good. The frequency FFT is not so good because it takes a lot of them. Now, if you change it into 1/8, here you can see that in the second segment, you have breakage. The frequency breaks into 2. It fracts into 2. This is the flexural response, the one that was added in channel 2. which was presented in a previous presentation, where you can have a map of that characterizes the damage. You don't have to locate the damage because you know that it is located at the neck of the probe, because that is the place where this is going to break or is going to damage. See, so you go right on, and there you can get as many modes as you can add, as you can measure. Here we have trends, the second or the third approach, the third method or approach, where you have trends on the amplitude. The trends changes because the frequency of the excitation, axial excitation changes, goes down, follows the resonant value of the probe. That is why you have this changes in the trend. You are beginning to increase and then you change the frequency. You cannot see anything in here in the actual axial direction. In the axial direction, you don't see anything, but in the other one, you can see a lot. You are able, with these three methods, you are able to estimate the pseudo crack depth and the crack growth rate. It is possible. With the first method, you rely only in a single data, the current one, the one that are implemented in the existing equipment. In the second method, you need to have the transversal measurement, and you can get 3 stiffness reduction parameters, 2 flexing one and 1 axial. So you will give you a much better estimation of the damage. And in the third method, the previous plus the amplitude. Here, finally, I propose some probe modifications, and I did some simulations, numerical simulations with a program. And here we can see the response once the probe is damaged. Here we have it at 10%. There is very little breaking of the frequencies, not the actual one, but definitely the flexular ones. Here we increase the damage in the simulation, and the actual is still a single one, but the amplitude of the flexural one of them is bigger than the axial one. Finally, we conclude that adding a second channel to the actual current very high cycle fatigue, as I proposed, is very, very useful. It gives you a lot of information, vibrational information, where the technology of the vibration can be incorporated and help you a lot. The flexing split frequency indexes plus 2 methods prove themselves capable to detect the damage onset based on 1 or 3 stiffness parameters. And the last one includes the amplitude data to quantify the damage. And you can also get a final element testing in order to find out what would it be the new design, where I propose to add 2 concurrent frequencies, natural frequencies, the axial one, which is important, definitely necessary, but also in conjunction with 1 flexing vibration, another flexing vibration. Okay, this is my presentation.